Good day everyone. My name is King Joshua O. Milagrosa, and today I will be going to discuss to you some topic about flexural members, which is the doubly symmetric compact I-shaped members and channels bent about their major axis. So first, ano nga ba yung flexural members? So flexural members are slender members that deform primarily by bending moments caused by concentrated couples or transverse forces. So in modern construction, these members may be joists, beams, girders, spandrels, lintels, and other specially named elements. So classification of steel section. So dito meron tayong tatlong classification. So first is yung compact section, second is non-compact section, then third is yung slender element section na may dalawang klase, which is yung stiffened element and yung unstiffened element. So for compact section, a compact section means that the section can achieve the plastic moment with local buckling on the web or the flange. So dito, provided yung adequate lateral bracing. So for compression flanges of I section and channel section, so dapat yung quotient ng base flange all over twice the thickness of flange is less than or equal to the quotient of 170 over the square root of Fy. So for webs in flexural compression naman, dapat yung quotient ng D over thickness ng web is less than or equal to the quotient of 1,680 over the square root of Fy. So punta naman tayo sa non-compact section. A non-compact section is a section that can reach the yields for the lower and bottom fiber only without causing local buckling to the web or the flange. So with a non-compact section, yung one or more elements sa beam is may posibilidad na mag-buckling before the beam is able to attain or obtain section plasticity. So, for compression flanges of I section and channel section, so dapat yung quotient ng base flange over twice nung thickness ng flange is less than or equal to the quotient of 250 all over the square root of Fy. So, for webs in flexural compression naman, dapat yung quotient ng H over thickness ng web is less than or equal to the quotient of 1,995 over the square root of Fy. So, for slender element section naman, a slender element section is a cross-section possessing plate components of sufficient slenderness such that local buckling in the elastic range will occur. So, ito ring section na ito is yung some part of the section is nagbabakal na siya bago pa man magbakal yung buong section. So, sabi ko nga kanina, may dalawang kind siya. So, first is yung stiffened element which is supported along two edges and parallel to the direction of the compression force. So, yung unstiffened element naman is supported along one edges and also parallel din siya doon sa direction ng compression force. So, for compression flanges of I section and channel section, so dapat yung quotient ng base flange all over twice the thickness ng flange is greater than naman or equal to the quotient of 250 over the square root of Fy. So, for webs in flexural compression naman, so dapat yung quotient ng H over thickness ng web is greater than or equal to the quotient of 1,995 all over square root of Fy. So, here, may provided sample problem tayo dito which is a design problem. So, sabi dito, select the lightest W section which is yung Fy is equal to 340 Y MPa as a beam using LRFD design method. So assume only flexure must be considered. So the dead load is given is in addition to the weight of the beam. So consider din daw na yung beam is mayroong continuous lateral support. So ito yung beam natin which is 6 meter. 6 meter. So then yung ultimate uniform distributed load natin is unknown pa siya. So given yung service load natin na dead load tsaka live load, which is yung dead load is equal to 13.31 kilonewton per meter, then yung live load naman natin is equal sa 29.18 kilonewton per meter. So using NSCP 2015 specification is kunin muna natin yung WU. So using LRFD, yung WU natin or yung ultimate uniform distributed load natin is equal to 1.2 multiplied by the dead load plus 1.6 multiplied by the live load. So equal siya sa 62.66 kilonewton per meter. Then kunin din natin yung PU natin or yung equivalent concentrated load natin, which is equal to 1.4 multiplied by the dead load. So equals yan sa 18.634 kilonewton. So since LRFD yung gamit natin, so mag-govern tayo dito sa WU para makuha yung ultimate moment natin. So yung ultimate moment natin is equal siya sa WU multiplied by length squared over 8, which is kapag sinubstitute natin yung mga given values, makukuha nating ultimate moment is 281.97 kilonewton. So, since design problem tong sinasagutan natin, assume natin na yung lambda is greater than lambda p for a compact section. So dito, required na hanapin yung Cx para makahanap tayo kung anong type ba ng W section yung gagamitin natin. So for Cx is equal yan sa nominal moment all over Fy is equal to ultimate moment divided by the reduction factor all over the Fy. So by substituting again all the given values, makukuha natin na yung Zx natin or yung plastic section modulus natin is equal yan sa 908,115.942 mm3. So from the table, select the highlighted section with Cx is greater than or equal to 908,115.942 mm3. So using the accept still section, so makikita natin dito na etong Zx natin is malapit siya sa 1,090 times 10 raised to cube o 1,090,000 na plastic modulus. So etong specification na to is a W18 by 35 steel section. So yun yung ating gagamitin. So ito, W18 by 35 na steel section. So yung relevant properties nito is itong mga given na to, which is magagamit natin sa pagsosolve. So at the moment caused by the beam self-weight. So alam naman na natin na yung nakuha nating ultimate moment kanina is 281.97 kilonewton meter. So i-add lang natin yung moment caused by the beam self-weight, which is ito. So ipa-plus lang natin yung 1.2 weight ng self-weight multiply by length squared over 8. So by substituting all the values or the given values, makukuha na natin yung bago nating ultimate moment na 284.73 kilonewton meter. So dito naman, compute the design moment strength of W18 by 35 steel section. So para sa width thickness ratio of W18 by 35 natin, so unstiffened element siya. So yung plunge natin is equal to lambda plunge is equal to base ng plunge over yun nga twice ng thickness ng plunge is equal yan sa 7.06. So for stiffened elements naman, so since yung beam natin is hot rolled, so the web is compact for all hot rolled member in steel section table for Fy is less than or equal to 448 KSI. So for the limiting width naman or yung thickness ratio, so refer to NSCP 20 table 502.4.1. So yung para sa plunge natin, so lambda plunge is equal to 0.38 times the square root of E, which is equal yan sa 200,000 MPa all over Fy. So ang sagot diyan is 10.79 para sa plunge natin, which is greater than 4.59. So therefore, consider siya as compact. So sa web din natin, ganon din. So compact din siya. So since plunge and web are compact, refer to NSCP section 506.2. So dito sinasabi na yung nominal flexural strength or the MN shall be the lower value obtained according to the limit state of yielding plastic moment and lateral torsional buckling. So for our yielding, so MN or nominal moment is equal to MP is equal sa Fy times Zx is equal sa 345 MPa, which is given sa problem natin kanina. Multiply lang natin yan sa Zx, which is yung plastic modulus natin na 1,087,940 mm3, which is makukuha na natin yung nominal moment natin na 375.34 kilonewton meter. So for our lateral torsional buckling naman, so sabi dito, since the beam has a continuous lateral support, so LB natin ngayon is equal to 0 and lateral torsional buckling does not apply or LB is less than LP. So kung nagtataka kayo bakit naging 0 yung LB natin, so from the beam kasi natin, yung entire length ng beam natin is assumed na fully laterally supported siya. So, ibig sabihin, walang magbe-bend na, or walang magbe-bend dito sa beam natin na ito. So, yon. So, since yung nominal moment natin is equal to yun nga, 375.34 times 10 raised to 6 Newton millimeter. So, converted na siya from Newton millimeter. So, dito na tayo mag-govern. So, dyan na nga tayo mag-govern. Then, the design ultimate moment strength is, so, ito na yung gagamitin natin. So, ultimate moment na natin ngayon is equal na sa reduction factor multiplied by the MN. So, yung reduction factor natin, guys, dito is equal yan sa 0.90. So, by substituting na, yun, 0.90 multiplied by 375.34 times 10 raised to 6 Newton millimeter. So, makukuha natin bago nating ultimate moment is 337.806 times 10 raised to 6 Newton millimeter, which is mas malaki siya kumpara sa na-compute natin kaninang MU na 284.73 kilonewton meter. So, therefore, masasabi natin na yung W18 by 35 beam is sufficient siya. So yun lang para sa discussion. So, maraming salamat.